Hey, it's Doc Williams, and in this video, we're going to predict the products of a single displacement chemical reaction and then balance that chemical equation. To review the types of reactions, watch the video 5 Types of Chemical Reactions. First, let's identify the characteristics in the reactants. We have a single element here, which we can label A, plus a compound, which we can label B, C. Now, my choosing the letters to label these is just because I wanted to go in order A, B, C, D. I wanted to use the same format that I use when I identified the components of the 5 types of chemical reactions to help me better predict here. So looking at the letters that I chose, we can see that this one most resembles a symbol displacement, where you have a single element A plus a compound BC. And by the way, you probably want to take a screenshot of this if you don't already have this in your notes from when we went over this in class. So following the rearrangement of the bonds for a single displacement, we see that A is going to displace B and form a new compound with C and leave B off to itself. So to follow that, I'm just going to write A, C plus B, then plug in my products based on this new formula. Now, before I write my new product in the products area of the chemical equation, I'm going to do a little work on it over here. A is magnesium. And if we look at the periodic table, we will know that magnesium has a 2 positive charge because it's a metal, it has 2 valence electrons. It wants to lose those 2 valence electrons, which will give it a 2 positive charge. C is chlorine, and chlorine has a -1 charge. If we look at the periodic table for chlorine, we see that it has 7 valence electrons and it prefers to gain an additional electron than lose 7. So therefore, it will form a -1 charge. So we're going to use the crisscross method to take the charge of the metal and use that as the subscript for the nonmetal. And then the charge, when we don't see a number here, is understood to be 1 of the nonmetal and use that as the subscript for the metal. That will give our new chemical formula for magnesium chloride as Mg. And whenever there's a 1, we don't have to write that. That's understood. And then Cl2. I'm going to plug that in right here. Let me write that a little better. Plus B, and we know B is is hydrogen. Now, when we write hydrogen by itself, remember this is a diatom, so it will always exist naturally in nature in twos. Now that we have our products, the last step will be to balance the chemical equation. And to do that, we're going to set up our tally sheet on both sides. On our reactant side, we have magnesium, hydrogen, and chlorine. That's our tally for each type of element on our reactants. We're going to do the same thing for the products, and I'm going to match up my tally on my product side to that on my reactant side just to make it a little easier when I'm counting atoms. My initial count, I have 1 magnesium on my reactants. I have 1 hydrogen on my reactants and 1 chlorine on my reactants. My initial count for my product side, 1 magnesium, 2 hydrogen, and 2 chlorines. Now, I've found as a trick that normally if I go ahead and balance my hydrogens first, since this is over here by itself, it tends to help with balancing everything else. In order to balance my hydrogens on my reactant side for my products, I am going to add a 2 in front of hydrogen chloride and then recount. So I still have 1 magnesium. Now I have 2 hydrogens and now I have 2 chlorines. And if I check this side, my products, then I see that everything is balanced out. So the answer for this one is magnesium plus 2 hydrogen chlorides will yield magnesium chloride plus hydrogen. And recall this is a single displacement reaction. As always, thank you for watching.